So first of all, I want to thank everybody for taking time out of their busy schedule to watch this webinar. We've had some very, very positive feedback over the years with regards to the content. In fact, to the point of it's so detailed in certain aspects that I find that people will actually watch the webinar multiple times over the course of a year, say, just to pick up different pieces that they may have missed the previous time. For those of you who don't know me, my name is Jason Spangler. I am the flooring division manager here at Wagner Meters. I'm responsible for not only the Rapid RH and the concrete side of stuff, but I'm also responsible for the small line of hand meters we have for testing wood subfloors and finished wood products. We're going to do a Q&A section. I'll try to get to as many of the questions as possible. If for whatever reason, either after this, you remembered a question you wanted to ask that you didn't get to or I didn't get to, or you have something in the future that you want to discuss, my direct contact information is 800-634-9961 extension 235. So before I get into the Q&A section, one thing that we're not able to really cover off on is this little device right here. Part of the ASTM standard requires that you have some type of record of what the ambient conditions are during the testing period. And the smart logger that we just came out with is an ambient data logger that will data log the ambient relative humidity and temperature, and it interfaces via Bluetooth with a smart device. So either a iOS or Apple or a iOS or Android based platform. Nice thing about it is that it's very simple, very intuitive, something that gives you great information. You can take it onto the job site, hide it in an area where you can sit there and while you're gone, know exactly what the conditions were, so you can have that as another piece of your documentation. Number two, just to make sure that everybody is aware, I know that we do say something or we put something that flashes across the screen in the webinar that talks about it a little bit, but the ASTM F2170 standard within the last couple of months has changed as far as what the testing duration is. The testing duration has changed from 72 hours to 24 hours is all that's necessary for you to get a documentable number from an installation standpoint. So I like to at least bring those two things up because some people are not privy to them. So the first question comes from Anthony. It says, I used the Rapid RH on a newly constructed concrete slab. All 5 probes were consistently 98 to 99%, which was consistent with what the flooring contractor's RH probes were. I then used the Delmhurst Total Check, the older equipment, and recovered RH values ranging between 83 and 85. What can we contribute this variation to since we are in compliance with F2170 with both tests? By the way, we love the Rapid RH. So first of all, thanks for loving the Rapid RH, because I do have to say that we get a lot of very, very positive feedback on the system. Second thing is, I'm going to kind of pick your question apart just a little bit. Hopefully all the pieces will kind of mesh together to give the complete answer. So the first thing you say is a newly constructed concrete slab. So anytime somebody tells me newly constructed, based on what I know about the last 12 years of being in the commercial construction market, that typically means, you know, a 6-inch slab or, you know, maybe a little bit more in a building that hasn't been enclosed for very long. The slab may have been down for 90 days, maybe 120 days. Don't have any HVAC on. You probably have had doors and windows in maybe for the last 2 weeks. And you end up with a situation where you go out and you now test the concrete. Well, I would expect nothing more than extremely high numbers, and I mean 98, 99s, or at least in the high 90s. And the reason is scientifically the slab doesn't start drying until you have the building enclosed and you have conditions that are consistently appropriate for drying. So you have low relative humidity and reasonable consistent temperatures. In fact, when you go back and look at studies will show you that it takes, once you have consistent environmental conditions like that, it will typically take 30 days for every 1 inch of slab thickness for it to dry down to, say, an 85 to 90% relative humidity. So I pull apart your first part, the 98 to 99 on a new construction slab, based on my experience, very, very, very consistent. So those would be the numbers that I would sit there and look at and say, okay, if my device, the Rapid RH, didn't read that, I would really think that something was broke on my device. Now, on the other side, we'll just say other devices. One of the things you say is older equipment. Keep in mind that in 2011, the standard was changed. The standard was changed to compensate for the variations that we have from device to device. And they actually went back and they looked at the changes down the road, and when I say they, the ASTM committee, and they did testing with all of the devices once they had changed their sleeve configurations and once they had changed their sensor configurations so that everybody's equipment was consistent. So what were the changes? The changes were that the sensor had to read from the bottom, and the sensor could not be any more than 5/8 of an inch from the bottom of that drilled hole. It also had to have internal sealing in a sleeve if you were using a reusable sensor. There had to be some kind of internal sealing in there. Last thing was you had to have very definitive rings or isolation gaskets on the outside of the sleeve that worked to isolate the air pocket at the bottom of the hole. What we found out is that devices prior to that, you really had a varying degree of where they were reading at as far as in the depth of that hole that was drilled. And so when you know how concrete dries, where you have a lower relative humidity on the surface and a higher relative humidity on the bottom of the slab based on the drying gradient of the concrete, if you're reading higher up in that hole, you're going to get a lower than actual reading based on the science behind F2170. So sometimes the older equipment you found out there, if you were using older stuff, that the sleeves are not actually ASTM F2170 compliant. So you look at, is it F2170 compliant or is it F2170-16 or -18 compliant? Because that's when the changes are actually made to were made to the standard. If all of that is within, when the changes were made, because what they did was they went back and checked everybody's equipment once those changes were made, and if the tests are done consistently, from one manufacturer to another, you find that the results are within 2 to 3% of each other across the board. And that there is a table actually that is published at the bottom of the ASTM F2170 standard that alludes to that. If everything else is consistent, then what I look at is when's the last time the sensors were sent back to the manufacturer? When's the last time you actually performed a self-check on the sensors? To make sure that they're within verification, because the standard says that you're supposed to actually have them in a salt solution 30 days prior to every usage and have documentation of that, and that you need to send them back to the manufacturer once a year to have them verified by the manufacturer, which with today's technology being digital, usually it's going to be something where you end up either buying a new sensor or you end up paying a large amount for the recalibration of the rebuilding of the product. The last thing I find consistently is that somebody will go through and read the directions from a manufacturer on a reusable sensor. And keep in mind, we do have systems that are reusable. So it's even with our reusable system, is that you read directions, and the directions from the manufacturer say something like leave the sensor in the sleeve for an hour or half an hour after the sensor is equilibrated for the right time. The problem is the standard says that once you put the sensor into a sleeve that has sat there, in this case now currently for 24 hours, and you take the sensor and put it in there, that sensor, you will know that it is equilibrated when it does not move more than 1% in a 5-minute period relative humidity. So you put it in, you take a reading, you put the cap on it. 5 minutes later, you check it. Move more than 1%, start the clock over again. 5 minutes later. So usually what you'll find is that you'll find people will put them in there for, say, 2 hours and then start checking the delta of the changes. So that's not just for the first hole. If you are taking a sensor out of one hole and putting it into another hole, the same situation occurs there. You do not know that a sensor is acclimated until it has sat in that hole and does not drift more than 1% up or down relative humidity. To answer your question, usually what I'll find is somebody will take the sensor from a say 50% relative humidity situation, which is fairly normal for most environmental conditions. They'll put it into a sleeve that's been there for 24 hours, and the sensor is ramping up. So you wait a half an hour, you take a reading. It's still ramping from 50 to whatever that endpoint is. And so you take that, if you just look at it as a definitive time period, and you look at it a half an hour and take the reading and you're done, it's usually still ramping up, so you're still catching it on that drift on the upwards because the sensor has not fully acclimated. So those are just a few of the things, a few of the reasons why there can be issues. Some of the other issues that are questions that I get a lot is, obviously everything we talk about is that it's a very, very, very depth-specific measurement. The best information you're going to get is going to be at that 40% depth of whatever the thickness of the slab is. Obviously, when the slab's drying from one side, the situation is that in some situations you don't know how thick the slab is. So people ask, how do you find out? So obviously, construction documents on renovations, if they're doing any kind of trenching, it's great to be able to see that trench when it's open, to be able to see the thickness of the slab. If you're looking at elevated slabs, penetrations through the elevated deck, a lot of times they're not a tight fit to the penetrations. So based on that oversized hole for the penetration, you can get an idea of what the slab thickness or the profile of the pan decking is. Worst case scenario, you have a situation where you can drill. I have people that are out there that I've heard that are drilling smaller diameter holes in a couple of strategic places on a slab to be able to get comparative information to make sure that things are consistent. Now, once you drill the hole, you can use a piece of wire, push it down in the hole. Once it gets to the bottom, pull it up. Once you feel resistance, mark it off with a Sharpie, pull it out, and measure what the general thickness of the slab is. Again, is that perfect? No. Is the slab going to be absolutely consistent? No. But at the end of the day, when you look at the options of doing surface-based testing, you're getting a lot better information with the relative humidity than you are with that. There is also another option. There is a device out there that will get you, it tests topically. It sends a signal through the slab and allows you to get within about, I want to say it's within about a quarter of an inch. Great conceptually. The problem is that for most people that are doing moisture testing, it ends up being a little bit too costly to do. Last time I checked, it was about $2,500 for the device to be able to do that. The last question I get quite often has to do with pan decking and the fact that you have pan decking that has varying thicknesses. You have thick sections, you have shallow sections. First of all, ASTM standard is 100% completely silent on the placement of these sensors as far as do you calculate the 40% based on the thick or 40% based on the thin section. So it ends up being something where I have to go to, as far as what we recommend. And then on the other side of it, what I'm hearing people doing out in the field. So what we recommend is trying to identify the thickest portion of that pan, identifying that, calculating your 40% off of that, and drilling into that thickest part. So the question comes down to, how do you do that? One, they make some fairly inexpensive metal detectors, usually under $100, that you can use, that when you scan them across, they work a lot like a stud finder for a wall. You scan them across the floor. As you're scanning across, the signal is strong enough that it will pick up the metal in the shallow sections. So you mark off the first shallow section, go across, mark off the second shallow section. You know where you're at, and you know that the deep part is in the middle of that. The other part, or the other thing I see people do is that they will sometimes take smaller diameter drill bits and they will try to identify where that deep section is, and then measure off accordingly or grid off accordingly from that. So those are a couple of different options for it. Okay, it doesn't look like I have any other questions. So again, my name is Jason Spangler. Phone number is 800-634-9961, and my direct extension is 235. Thanks, and have a great day.